Hello, it's Duncan. Last time on Team Gilded Rose, we decided that we'd better monitor whether our application was working properly. So we added a filter to all of our routes that catch any exceptions and log them. And then we added a route to deliberately raise an exception so that if we hit that route, you can see down here in our logs, we get the exception printed out. Now we said at the time this wasn't particularly well tested because we weren't showing that logging was actually happening. And also logging is a pretty unfriendly way of monitoring our servers really. If you've ever tried to parse the logs to try and find out whether something was happening consistently, you'll find that it's a pretty horrible format. So today we're going to address both of those problems. Just before you arrived, I'd written a little test here which shows some of what happens when there's an error. So this test builds a fixture so that we actually start up the whole app, makes a request to our error route, and shows that the response that comes back is this internal server error with our body of something went wrong. What it doesn't show though is the side effect that happens, which is that we log. So what we'd like to do is extend this test in order to see that side effect somehow. Now a pattern that I've seen successfully used in these circumstances is the idea of events. Some people call them operational events. I like to think of them as analytics events. So we might have events to show that the system was functioning properly, and events to show when it's not functioning. So we're going to go on with this idea of events and see where it takes us. So events rather than logging. So instead of just logging any old strings, we're going to have a specific set of events that our application can raise and a structured way of writing them into our logs so that potentially we could parse the logs and put them in a database, graph them and so on. So if we're thinking in terms of events, let's say, what if we had a store of events somewhere that we could query in our tests? So what if we were able to say assert equals 0 is our events.size, and that after this response there was one event. Where would these events come from? Well, our fixture wouldn't be a bad place. So if we were to just hint here that because our fixture is this inside this block, then IntelliJ would allow us to create a member property of our fixture called events. So let's do that. And what would events look like? Well, we know we're going to add to it, so let's make it a mutable list of anything for now. And we can pull that up into the constructor like that. Okay. Size is a property. Do that and that. So this test is obviously going to fail. Let's see what changes we have to make in order to make it pass somehow. Well, our fixture has these events, but our routes don't. So let's try adding the events to our routes as well. And now IntelliJ knows it needs to create a parameter in our main over here. Let's go and see what it's done. So now we have some events. Okay, we'd like to add something at the point where we get this error. And in order to do that, I think what we're going to do is we'll inline this for now so that we have access to these events in this handler. And then as well as logging that error, we'll say events.add. And let's put something in there. Get our test passing with hello. Oh, and here in main, we can just create an empty mutable list. Let's try that. Now I have to confess that I expected that to pass, so let's go and have a look at our tests. It failed here. Oh, well, it failed because we were looking after the response. So let's do that. So before we make a request, it should be 0, and after it should be 1. Good. Now we probably don't want mutable list as our interface for our events. So let's go and have a look here. At the moment we're passing mutable list of any in another event. But really in the case of events we raise them, we just notify somebody about them. And the signature of notifying somebody about something is something that takes, it's a function that takes anything or an event and returns unit, which is to say nothing. And so here, instead of calling add, we'll just call that function. Now we'll have to fix some bits up, so we'll have to fix up our fixture. And what is the function here? Well, we can say that this is a function that takes the event and adds it to the event. So this would be events.add whatever that event was. So if we run this, and we still have this problem up here. Another way of expressing that is that if this was a mutable list of any, it's its add method. Okay, that's passing, but hello isn't a very good event. So let's create ourselves an event for uncaught exception. So we'll create a class, and we'll call it uncaught event. And let's give it the uncaught exception for now. So this is going to have a val, and we'll make it data class. So that's what we want to put in here. And that is our exception. And that will allow us to go back to our tests and show not just the events have changed, but that we actually have an uncaught exception event in our events. So what we can say is that events first, and let's take its class and say that that is uncaught exception event. Equality on exceptions is hard because we don't control what's going on here, we don't control the stack trace and those sort of things. But I think it's enough to say that it's the right type here for now. We'll do better later. Okay, so now we can see the structure of our test. We have tested two things. We've tested the response and we've tested the side effect. The response is that we have an internal server error, and the side effect is this uncaught exception event has been posted to something. Now what's that something? Well, now we know what an interface to our events would look like. We have the problem here that we are both logging and raising events in our main function. And here we're just adding events to a list that we're going to throw away. So now we'll go and write ourselves an implementation of our events interface suitable for our production code. We are test-driven developers, so of course the first thing we're going to do is write a test. Events is a bit of a general term, so I think we're going with analytics for our test. So we'll create a new test and we'll call it analytics tests. What do we want our analytics to do? Well, I think probably to spit out a JSON representation of our events. That way we can parse them and put them into a database that we can use to show that our application is running. We can print pretty graphs and so on. So this test is going to be that it outputs JSON of the events. Now we could use a logger to do that output for us. That way we could have rotating log files and all those happy things that loggers give us. But these days we generally just print a standard out, and that's captured by something and stored in some log aggregation service. Of course, capturing standard out isn't easy for our tests, but we'll cross that bridge when we come to it. Okay, let us write a test. We need some sort of analytics. and we know the type of that is going to be function type. So we know it's, at the moment at least, any to unit, and we will say that is our logging analytics. We don't have that type yet, so let's create it, and we'll do it in here for now. If we're going to implement those members, we get an invoke function, and we can call this our event. What should we do in here? Well, we want to output, and we normally count output again as a thing that takes something and returns nothing. So we might call it the logger, and a logger is a thing that takes a string and returns unit. If we had one of those, we know that all we want to do here for now is tell the logger, invoke that logger with our event, and we need to turn our event into a string somehow, and we have toString for now. Let's do that. And if we made the logger a property, that would compile. How will we see whether this is working? Well, we'll pull this trick of having a list again. So if we say I've got logged is a mutable list of string, I can pass logged add into here, and then I can say that 0 is my logged size. Before I do anything, and if I go to my analytics and invoke that with something, then I will have one thing in my log. I'm going to run just these tests for now. Good. Now, of course, that isn't what I want in my log. So let us say here that this is, at the moment at least, just a list of hello. And now we can go about encoding this event in a better way. So let us create an event with a bit of structure. And maybe our test event has a value which is a string. So instead of passing hello into here, we'll pass our test event with something like that string. And what should we see? Well, we'd like to see a JSON representation of that test event. So what we'd like to see would be something like a squirrely, the value, the name of the field, the value of the field, something like that. And of course that isn't what we have because we just had the toString on the event, which, as it turns out, isn't a data class, so it's even worse than you might think. So now we need to turn structured data class-like things into JSON. There are lots of technologies available for doing that in Kotlin. I know and understand json. And knowing that we were going to be using JSON today, I've already changed our build.gradle to import a whole bunch of json modules that I've found come in handy over the years. Okay, so in order to convert, we need an object mapper, and we can ask Jackson for one of those. And in here, instead of just doing event to string, we can ask the object mapper to write the value string of this event. And it passes. Now, just the properties of our event aren't very friendly. It would be nice if we also had the name of the event. So it would be nice if, as well as this, we had an event name, and if that was test event. How could we do that? Well, we could define a getter for test event of value for the event name, and that would be, this is class simple name, and that should be a string. And you'll see here that class simple name is nullable. If we ever got a null, that would be a shame. So if we did, then we should probably say event name unknown, and we should be calling simple name. Right, let's see if that works. It does. Now we don't want everybody that defines an event to have to remember to do this. So what we could say is we could create an event type, and we'll call it analytics event, because there are lots of events. And we could put this code into there. So if we cut that from there, we'll get that. And here then we can make this our analytics event, and it will inherit that behavior. We can then enforce this behavior on all of our clients by saying that the type of analytics is not just any to unit here, but is analytics event unit. So you must always pass us an analytics event, and that way we'll know that we always have this event name. And we can enforce that here and here. And before we go on, it would also be nice to know when this event happened. Now we could put that into the event, or we can put it in an envelope around the event. And I think we'll probably go with the latter. This time we won't try and write the JSON in here, we will paste it in when we're done. So we're going to create ourselves a class inside analytics, which is, we'll call envelope, and it is going to have a timestamp, which is going to be instant, and it's going to have an analytics event. And now let's try writing an envelope containing the event rather than just the event. Now we had the trouble that our object mapper doesn't support Java 8 types out of the box. So I'm going to go away and find some code that makes that work. Okay, I went off to another project, found a thing that looks like this. A little bit of importing. And we'll call this our logging object mapper. And that will be the thing that we use in here. Right, let's see whether that works. Okay, so here is our JSON. It looks good. It's got a timestamp and an event. The event has a value and a name. So let's take that and put it in here. Problem is, of course, that next time we run this, the time will be different. So we know that our normal way of solving that problem is to have a clock. To create one of those. What's a clock? Well, a clock is a function that takes nothing and returns us an instant. And we know that everywhere but this test, what we want that to do is return instant. Now, so here we can invoke the clock, and in our test though we can pass a clock into our analytics. Clock is a function which will return this timestamp. Pull that out as now. Put it in there. And let's see whether that passes. It does, wonderful. Now that type was only there to force IntelliJ to know the type of analytics, so we can remove that. And you can see here the typical shape of a test of code that only works by side effects, so that we have to show something was in a way beforehand, we have to call the code, and then we have to show that the side effect has happened. Something has changed in our world. Okay, now we've got some tested code. Let's move the production code into our production source tree. So we have logging analytics and this object mapper. I think before we do, it might be worth also saying, let's create ourselves a type alias for this. So analytics event to unit, bad name, this is analytics. Okay, so what belongs in our production code? We need the analytics event interface and the type alias and our logging version of that. And it's here, so let's take those, cut them out of here, create ourselves a new Kotlin class, a new Kotlin file called analytics. Add that and paste everything. This can be private, and let us suppress the unused for that class. And for the here as well, because IntelliJ doesn't know that we are accessing these via reflection from Jackson. So we have to tell it that we want to keep them. Right, check that that still builds and passes its tests. It does. Let's run all the tests just in case. Good. Now we have some logging analytics, so we can install them into our main. So let's have a look what we had. Now here we have events, which is any to unit. We now know that we want the type of our events to be analytics event. So let's replace that with our type alias. And for good measure, we'll rename this to analytics. Now you can see our uncaught exception event isn't yet an analytics event. We can fix that. Okay. And finally, we need to install the analytics we've just written up in here. So let us add names to the call arguments and put the arguments on separate lines. And now we want this to be our logging analytics. Where do we want to log to? Well, we have this logger, which is string to unit, and I think that is just system out println, or in Kotlin, println. Okay. Now, this is only installed in our production environment. It's not being used in our tests, so let's just run up our main and see what we get. Okay, so now when we invoke our error path, we have two things happening. One is the logging, which we can remove because we now are outputting a structured version, and there is this structured version here. You can see we've got a timestamp and we've got our event. This event isn't very friendly because we are outputting the JSON representation of the throwable. So let's see whether we can do a little bit of a better job there before we go on. My normal policy here is to put into the event the things that I want in the JSON. So instead of having the exception in the JSON, it would be nice to have the message and the stack trace. And the stack trace we can represent as a list of string. instead of this throwable. How do we get that from here? Well, let's add ourselves a constructor which takes the throwable, and that's going to take the message. This is not the message, this is, it's going to take the exception, get this message, that's nullable, so we can say or empty, and then we can take our exception and its stack trace, which is an array of stack trace elements, and if we map those to string, like that, and rerun our main and remake our request. And buried down the bottom here we have our JSON. And now you can see that we have a far nicer event. We have its message and we have a stack trace as an array of strings that look like we expect a stack trace to look. And right at the end, scroll, we have the event name, which is our uncaught exception event. So that code is all working. And while we're here then, we can also get rid of this logging and this logger and tidy this up to its own little function. Right, we're almost done. There's just one thing that worries me a little bit, and that's that we've already seen the fact that our JSON encoding can fail at runtime. So we can pass it things that it doesn't know how to serialize to JSON. So what we'd like is that when we're running our tests, we not only get the opportunity, as we did with our uncaught exceptions test, to see the events, capture them, but we'd also like to try and put them out to standard out in order that we can see that we can encode them. Let's have a look at how we might do that. Look in the fixture, and the fixture is currently saying our analytics is add to our events. Well, what would be nice is we could do both. What we'd like is that we could take this mains analytics, this one, let's move that out into a property at the top level. It would be nice if we could use that. And then add to the events. Can we do that? Well, this is a function, and we could create an extension function on our analytics. IntelliJ is a little bit confused here, but it's got the signature mainly right. What we actually want is analytics, then some more analytics. Analytics is just calling a function, remember. And this should itself return an analytics. A function from analytics event to unit. A function that takes an analytics event and returns nothing, just works through its side effects. So what's an analytics look like? It needs an event. So this is going to return a lambda, which takes an event and feeds it first of all to this and then to that. Now this works sweetly because we have defined our analytics as a function type and we can compose functions. So now when we go to run all of our tests, you see that as well as capturing the event in our uncaught exceptions test here, if we go down through our tests, you'll see here on standard out we also have our logged event ready for our log aggregator to parse and ship off somewhere to display pretty graphs. So recap then, we've expressed our analytics as a function that takes an analytics event and just has a side effect. And that side effect, in the case of our production code, is to log to system out and to encode our analytics events as JSON. But because we're using a simple function type, it means that we can implement that in a different way in our tests in order to see what events, in order to capture what events have been raised, and compose the functions as we did in the fixture to do one thing and then another. Okay, I think you can trust me to commit this and push it to production, and when we do, we should be able to see, at the very least, if it fails. Now that we have some structured events, we are going to be able to use them to see how often our app is used, as well as whether it's working, and we can probably integrate that with some better error handling as well. If you'd like to see that, then please subscribe to this channel. And if you like this and you're a Java programmer, I think you'd love the book that I wrote with Nat Price called Java to Kotlin, a Refactoring Guidebook, published by O'Reilly. Thank you very much for watching.